Hello everyone, this is Bradley. Today we're going to do this plasma animation, which I initially did for November 2019. I hope you have seen the renders and its demonstration. This animation is completely procedural and real time. Several things I have to mention in advance. This tutorial will be at least separated to two parts. One is to get the general shape and possibly some aspects of shading, and the second part will be about how to get interaction between plasma and the inner and outer spheres. Additionally, there is also a concept of shading which I may want to discuss in a separate tutorial. At this moment, I don't know if I want to integrate this knowledge in these two parts of tutorials or not. It depends on the length of each tutorial in general. Another thing is that I found a new way of working this animation out. If you have watched the demonstration and think the node tree is huge, don't worry, it will be much shorter and simplified in the end of this tutorial. So let's do the optimization together with this node tree. So firstly, let's briefly discuss the principle of this animation. So the principle is that I'm going to create a point on each of these spheres. If I connect these 2 points, then I have a spline. And if I add more points on this spline and add some curvature, then the spline will curve. And this is basically done. The rest is all about the shading. And of course, the interaction between all this plasma or spline to the both of sphere will be discussed in the second part of this tutorial. So let's start to firstly, we need to project point on the surface of this sphere. I'm going to use a concept which is called a BVHtree. You just search BVHtree, then you have ray casting. And now we have a complete new socket which is called BVHtree, and it's dark gray, which is completely different from dark blue, light blue, and yellow. And to do this, to have an input, of course, you can just shift the A goes to BVHtree to find whatever point. Other possibility is just select the node, hit W, and goes to data input, and select the BVHtree. Then it will automatically give a possible input. This is never the only option that you can have, but it actually at least give you kind of idea about what else you can actually do with this. So you need a vector list and the polygon indices. To do this is basically object mesh data and select outer sphere. I'll basically name them outer sphere, actually just outer, and inner. And the vertex location, basically go to vector list, and I need also a purple list, so I just hit U, goes to socket settings, and turn on the polygon indices. So purple goes to purple. So now if I have a 3D viewer, you can see automatically there is a point generated on the surface of this sphere. So for demonstration purposes, I'm going to create an empty, and I'll put the empty into control. So for my preset, I basically already add all these triggers. So in the collection, which is called controls, so anytime a location, scale, or rotation has been changed, it will execute this node tree. Because I want to turn this always off so that it does not burn my computer. So you can also take a look with this number. If you turn on the always, then this number will always change. It basically will burn your computer even while you don't necessarily to execute this node tree. But with this trigger, so each time if I move this empty, then this node tree will update itself, while when everything is in rest, my computer will not be burned out due to this node tree, which is very handy. And in this case, I'm going to put object transform input. You don't necessarily do this. This is just for a demonstration purposes. Select this empty. So now if I move these empties, then there is always a point being generated on the surface of this sphere. The only exception is when the location is in the center of the world, then it does not know which direction actually will go. But even if you just have very minor deviation, it's a pretty precise projection on the surface of sphere. So basically the BVHtree, you can know more from Wikipedia, but the basic idea is it's just create a bounding box, a kind of precise bounding box on the geometry. So this kind of concept can also be used for kind of physics, like collision, cause smoke rigid body, and so on, all sorts of kind of things. But instead of using empties, we are going to create vectors. I'm going to create random vectors using this vector wiggle node. And if you try to create a list, because by the end of the day you want multiple points, of course, but you cannot create a list because it does not accept multiple inputs. So we need a loop input, and probably vector from value. And put it back to parameter. I'm going to evoke these subprograms and just increase the value to whatever number. So if the amount of iteration means amount of points I'm going to generate. So to show you, I'm going to make a vector list. And if I put this output outside this loop, you can see it's still nothing changed because for each loop the seed stays the same. For the seed to change, you just basically put index to seed. Then instantaneously, if I have 5 iterations, then I have 5 points being generated. And you can create as many points as you want, of course. So now we project the points on the outer sphere. We also need to do the same thing for the inner sphere as well. So basically, I just duplicate all these nodes, but change the object into inner. And the direction will still be the same for the vector wiggle. And after we finish this part, what we are going to do is to combine this list. So create vector list. So location 1 and location 2. And for these locations, I will input basically to spline from points and curve object output. So if we put both points into spline from points, then it will generate a spline between these 2 points, and put a spline to the curve object output. So just activate that. So you can see if I'm going to hide this outer sphere, you can see there's a point being generated inside, right? And then of course, if you go outside the loop, then multiple splines will be generated. So for this part, basically this is done. But of course, we need to generate points on these splines, right? And wiggle that. So how can we actually do this? Because now we only have these 2 points, right? So easy way to do this and is basically just to create another splines. So we need evaluate splines and evaluate range. So now we have an amount. This number is very important. So if we now put the 3D viewer, you can see there's 4 points being generated on this splines. If I just increase the number, then I have more points. And basically, I'll just plug this back to the parameter for future use. And now I need to wiggle these points. It's also simple. For some reason, I'm going to create another loop. Now they have 2 colors which are very similar to each other. So I'm going to change the color, like make it blue. Looks nice. And it's kind of easy to do. You basically just add a vector wiggle. Index. and the vector goes to B, and the other vector. So name it curvature size or curvature. Yeah, I turn on the curvatures, and now if I output this vector list, so you can see how it actually looks. So now all these kind of points flies away, but if you decrease its value, then you have a kind of curved point. If you connect them to splines, of course it will work. To connect them splines, it's basically just to do the same thing, just to repeat what you have done earlier. Spline from points and creates a target. And I also need a smooth bezier spline. But also one thing that you probably realize is now all these kind of points actually go off from the surface of sphere, and this is obviously not what we want, right? To fix this, however, is actually very simple. It's just so the concept is easy, that if this point is at the beginning, or if this point is at the end, I want to cancel this vector wiggle. To cancel that, you just need a math. Like if you times everything with 0, then no matter how you increase the size, it does not affect that, because finally the output will be 0. So you add nothing all the time. To make it easier, so each time if you need multiple, you need a single value to control x, y, z, you always need a vector wiggle. But there's a more simplified function which is actually called a scale. It will update a single number to x, y, z at the same time. And then next step is, how can we know which point is at the beginning and which point is at the end? So for this kind of condition decision, we need a node which is called a switch. So when the point is at the beginning, then it will output 0. When the point is at the rest, then it will output 1. So this is kind of thought. And of course, to know their actual location, I need to compare. So is that at the beginning, or is that not at the beginning? So I need to compare this. And to compare, to know their exact location, I'm going to use this index. And that's why I need to generate a loop in this case. So as you know, the index always starts from 0, which is also a number for the iteration -1. So if the index is 0, which means it's basically the beginning or the end of this entire list, then it will always stay the same. So now all the points flies away, see? So now if I change this curvature, there is one point which always fixes at the place. So what about the other points? It's basically still the same. I'm going to do the exact same thing. Duplicate these numbers. And I'm going to compare. And for this compare, now I need to know the index number at the last list. And as I said, the maximum index is basically iteration -1. So I need to basically just float math. Subtract 1, which is very handy. Iteration subtract 1. And now I need to put this index back. So now basically everything has been done. So now if you can obviously increase this curvature, it does not change a thing. And this is very handy because if we go back to the beginning, even if we increase the number of this kind of points generated between these within these splines, you can see the beginning is still the beginning and the end is still the end. So they will never change. They will never be wiggled, regardless how many inner points you have, which is kind of handy. That's why it's completely procedural. Very awesome. 0.4, 0.03. Just change the number. A little bit will be fine. Just yeah, I think this is fine. You can tweak more later on. So what to do next? Oh yeah. Now now we included everything within the loop, which is okay, but you only generate one spline from everything. So I'm going to create an iterator object list, and I need an object instance. I'm going to just use the target I created. I will instance this target and it goes to object list. I'm going to connect object to object. So now if I just increase this instances number, then it will be fine. If I create 11 instances, then there will be 11 different plasma being generated. And that's good. So basically this animation, up to this moment, everything has been done. You can tweak a lot more stuff. For example, you can just make the bevel size different for each plasma. The way to do is basically random number. Put the index, and I'll probably just put both of these numbers back to the loop so that I can control that later on. Up to this moment, I think it's basically done. Also, here's the one thing that you may want to do is, what if I want a spline to have different radius? What if I want to have different radius even within the same spline? Then it comes to a point where the radius starts to work. So sometimes you might wonder what's the difference between radius and the bevel depth. It seems like they're doing the completely same thing. So if I just cut that, so if I increase the bevel depth, then I have a radius. But if I increase the radius, I also increase the thickness. So it seems like they're doing completely the same thing. So what's the difference? The difference is that for the bevel depth, you can only input one number, but for radius, it will evaluate the points on the curvature and you can put different radius into them. Actually create a random number and create a list. Count goes to count and the numbers goes to radius. So now it goes to be also weird, but you can't. I think you can kind of get the idea. And now this random number will always keep the same. To change that, you just put an index. I mean, I'm not recommend you to do this, but at least this is a thing that you can do to create some variation. So even if it's kind of subtle change, sometimes it makes a difference eventually. And another thing I want to remind you is the reason I'm using vector wiggle all the time instead of random vector is because I have evolution. So maybe it's not very obvious here, but you can definitely evolve this vector wiggle. So you can just change its number so that it rotates around. It's giving you kind of idea. The same will occur on this thickness. But practically speaking, I think you probably want make the speed large enough so that you can actually observe its change. Up to this moment, as I think I've talked about everything which is available for this animation. And again, the interaction between these splines and all these spheres will be discussed in the second part of the tutorial. Let's just make a viewport input for this. If you understand all these concepts, I think you just can optimize all these kind of things by your own. So far, I'm just going to So next step is talk about the shading a little bit. So if I turn up the scene, firstly I need a HDRI environment. I'm basically just to take whatever looks nice, and I'll add a materials for this sphere. There are multiple things that we can potentially do, but I probably will add a shader and also a mix shader. So the idea is I need a layer weight. So I'm going to use this layer weight, which you can also think it as a personnel. It actually does not matter how you actually call that. And instead of using blend to control, I usually prefer use color ramp to control everything because I think it's more precise. And you'd have definitely other options to control these kind of things. So now I create such kind of gradient. I'm going to make the dark places transparent. And to make it transparent, I probably need back curlings. Turn on other options which will be available, and make it alpha blend. And I will make the inner as the same material, so just sphere. The reason I need to add a shader because I also want to add some feature for this sphere. Let's take a Voronoi texture. And to add some color, it's essentially straightforward. Just to make a mix RGB. I think this is basically done. Yes, it's probably glossy will be better than the emission. And if I turn this emission down and turn up some more Voronoi, I think all these kind of things you can test by yourself. So probably not going to discuss too much. And of course about lighting and other things. So let's then talk about this in the target. Because remember that when we instance this object, we also copy the full object, meaning that the shader will basically go with all this object. So now if I add a material, For example, if I change this color to red, and then if I activate everything again, you can see the shader has been updated to that. What to do next to make it a random color is that I'm going to create a texture coordinate, no, object info. And I probably need an emission. I need to use this random socket. I have a preset, basically rainbow. In this preset is basically super simple. Now I just create a random crappy colors. If I turn off the balloons, then it will be looking fine. I want to turn down the thickness a little bit, so then of course I can increase the instances. So now it looks like this. I think this is pretty cool. Not bad. Not too bad. Within this rainbow, it's basically just a rainbow, a rainbow cyclization. Not anything fancy, but the moment you put on this fake user, then this node group is in, and you can share this group for different materials, which is very handy. So at this point, this is done. Here's a point that I will also make a different tutorial for this about changing the random seed. So I will put in the link, so you either goes to cards or you can watch from the link in the description, but I probably won't share this idea here. So I think this is done. I don't know how much time actually I went, but this is it. Maybe I'm wordy at some point, but I hope you understand the entire process. And you definitely, now this node tree looks kind of very messy. This is how I usually work. But you can definitely organize this more. So I think that's it. I hope you enjoyed this tutorial, and I will probably see you in the next part. Bye bye.